These slides are about the developmental learning that I did in 2025 or 6 months. And slides have been categorized into two types. One is for the development and another is for the learnings that I had. So these are the topics that we are going to cover in the development category. So the first one is LangGraph implementation. Previously for the Amplitude we have been using the LangChain. Now we are moved to the LangGraph. The main reason is it has a state of mind to know what the state of the agent execution. So suppose if it has a different workflow means like moving from one state to the another state, it will remember what it has done in the previous state. So depending on the previous results, it will control the branching of the workflow. So that's the main reason for implementing the LangGraph. And for the master Excel, we implement the Llama index. The reason here is it can able to access the multiple tools simultaneously, which in our case we need to access the knowledge base, product catalog and factory layout simultaneously, like getting the knowledge base context and the product catalog context and factory layout context together as a final output to the LLM. I will explain this in the diagram. Here it is very similar to the LangGraph, but instead of using the graph workflow, we are having the multiple iterations of the agent accessing the data sources. So we used to define this in the prompts, but it will identify what has to search in this data source depending on the previous results. So that's the main advantage for this implementation. And this is the example. Here you can see the user asking, can we place a conveyor belt in the existing layout? The first it is going to get the model list, data source where it is searching for the conveyor belt and identifying the model name. Next it is going to the factory layout and getting the factory layout dimension informations along with the models available. Then it is again going to the factory layout to get the existing models dimensions. So in this case you can see it is not searching for any type of particular type of models. It has been already identified, okay, these are these models, I need to get information only for these models. So in the factory layout it is getting the information only for the model that already exists. So it doesn't look for all the list of models available in the product catalog. Now for the report generation, we have included a option to create a report for all the predefined prompts, and later we can able to download it as a docx format. We also have a CSV export module also, but it is not integrated in the main module. The reason why we are having this option is to create a data frame where the LLM results are stored, and finally we have to extract the information in the CSV format, because for the Meriora client they have been working in the CSV Excel sheet format. So to match that we implemented this module, but we didn't integrate it in the main module. And this is the results for the report generation, and this is the result for the report downloaded for report that has been downloaded. Here you can see the source information is given along with the page numbers. We'll talk about that in the coming slides. Okay, the source document. What we have done here is we have indexed the chunks along with the metadata obtained from the PDF, so that the metadata contains the document name and the page number where the chunk has been extracted. So when the LLM is giving the final results, it will access the metadata from the retrieved chunks and give the final result along with the answer. But the problem here, we also have a problem here. The problem is sometimes the page numbers are not giving giving different values. The reason is some documents will not have the metadata, so while chunking it will store the first page, the chunks retrieved from the first page as a page 1 and second page as a page 2, but in the original document the page 1 and page 2 will be defined further down like after crossing the document name or contents of the documents, and maybe after 3 to 4 pages the page number 1 will start. But in our case we will consider, while chunking, we will consider the page 1 data chunk extracted from the page 1 as a page 1. So this is the reason why we are having the mismatch of page numbers in some documents. It also applies to the docx format, doc format documents also, because they don't have the page number information embedded. This is the page number, this is the source information that we are getting in the module. Later we also created a feedback system, like when we ask the question to the LLM, it gives the answer. Now we have an option for the user to give opinion on the answer, whether it is right or wrong. If user is giving modified answer, okay, the answer you gave is not right, this is the answer we need. If user provides this answer, this information will be embedded, will be added to the index. So whenever in the future similar kind of questions asked, it will retrieve the updated answer. But this is only a command line interface. We experimented in the command line interface only. Parallel execution. In LLM, we can run, in the Llama index, we can run the multiple tools simultaneously to access the information at the same time. The reason why we using this Llama index is we need to access the information simultaneously for 3 data sources that we have in MasterX: knowledge base, factory layout, and the product list. But we have a problem in this. Suppose if you are giving the parallel execution for more number of tools, then it will create a bottleneck utilizing all the resources in the virtual machine or system it is running on. So we need to keep track on the limit. Then next was the fine-tuning OpenAI model. For the WSP, we created a samples from the documents they provided, and we used that samples to train the OpenAI GPT-4o model. It was performing very good. The reason why we fine-tuned is we need to get the predefined answers for the user questions. So it won't search for the index, or it won't try to give the answer at that moment, because the samples will, in the samples we already have given the results and trained the model, so it will give only that answers. But the problem here is we have to check the samples for authenticity, whether the sample generator is having the correct question and correct answers for that question. And also it is very costly. The model we trained was around 300 euros for training and deploying. So yeah, it is very costly. And so the reason why we move to the open source alternatives is to tackle these kind of fine-tuning problems, or utilizing the customized models from the ChatGPT or any other vendors. So at the time the DeepSeek was very famous, so we tried to deploy it in the virtual machine, but we used only the 1.5 billion parameter model, which is the basic one, and we deployed using the Ollama hub. The performance was not that good compared to the OpenAI. Obviously it has only 5.5 million parameters, but it will be useful for the small scale applications where the data amount is very small, and also the execution time is very long, because it has to utilize the local VMs or local laptops, CPU or GPU power. Also, we experimented with open source document extractor and vector databases instead of document intelligence and AI search, just to experiment whether it will be on par level with document intelligence or Azure options, Azure model options. For the document extraction, it is an excellent alternative for simple documents without having any complex data like complex tables or images, data from the images. Even data from images also we can able to extract it, but images will take more time, because it has to run the OCR to get the information from the images and all the things. but according to me it is the best alternative for the simple documents. But even in the document intelligence also we have a problem in tackling the tables. Like tables means tables are having the checked marks or X marks. So it is still it's a problem in dealing with complex tables, even in the document intelligence also. Open source vector database, we deployed our module using the FIAS database. It is very quick, but it will take time to index the documents. But while retrieving, it was very quick when compared to the OpenAI API calls, because FIAS is using the local systems resources. So for that, it was performing very well, and also the answers was very to the point. But the reason why it is behaving bad, because when compared to the OpenAI, definitely it is not performing that the results we got in the Azure AI search. But if we give the query very specifically, we can get the results more accurately in FIAS. So this is what I got the impressions of using the FIAS data, FIAS vector store as a primary one. So my thought is it is the best choice after AI search. If the document is very small, or if it need to get information very specifically without any unnecessary information, like very specific to the point. Later for Master XR, we used Fast API to create the API endpoints. The AI module is implemented using Llama Index, as we seen in the previous slides, and we have created 4 endpoints: JSON upload endpoint, recommendation, validation, creation. The data source is the knowledge base, JSON layout, and product catalog. Knowledge base will have the heuristic rules for planning the factory, and JSON layout will have the current coordinates or all the informations of the layout and also existing models. And product catalog will have all set of models that are available to place it in the factory layout. So the recommendation endpoint will provide the suggestions to the user how to design the factory or any layout. And validation verifies a simple set of checklists we have that complies with the current layout. Then last one is a creation endpoint. This endpoint, we haven't finalized this endpoint execution, because either it has to return a JSON, modified JSON after placing the models that are available in the catalog, or it should give only the commands to place the object in the layout. So we haven't completed this creation endpoint. By the validation, we have given some simple checklist questions to check whether the existing layout is complies with the heuristic rules or not. So the JSON upload endpoint will receive the JSON file from the Unity environment. So once it is uploaded, it will get indexed, and it will be available for the API calls. So all the API calls are asynchronous. So they don't have to wait for the one API call to end, so it will execute simultaneously. That's why we are using the maximum number of workers in the Llama index to manage the API call simultaneously. So this is the sample that we received from the Fast API web interface. We uploaded the warehouse JSON, and we are getting responses. Index created, uploaded successfully. This is a simple question we gave: name the objects installed in the current layout. This is the response we're getting for the recommendation endpoint. So my learnings for the past 6 months is, first of all, I don't know anything about the Unity when I was starting the Master XR. So I just Ilya advised me to go through this basic Unity course. So I just went, I think it was 7 to 8 classes. I think I just went through this course. just to understand what Unity is, how to maneuver the tools inside the Unity environment. And a fast API endpoint. Before I was not aware of these endpoints, implementing these endpoints. So I just read a lot of documents and the things that we can implement it for our use cases. So it was a very good learning curve for me, especially with the fast API deployment and agent workflow. Each framework is having the different kind of workflows, like in the LangChain or LangGraph or Llama Index. Even in the LangChain, Llama Index and LangGraph, we have different types of workflows for different use cases. Like whether like using the React agent or a simple agent, different alternatives was there. So it was a very good experience in going through these kind of workflows in these frameworks. And indexing alternatives, I read a lot about this indexing alternative, because the main reason that we main problem that we face in our already deployed modules is indexing the documents. Because if the documents indexed well, if the documents were indexed in a proper way, then retrieval will not be an option, will not be a problem to give the right results. So I was researching on what the different types of indexing methods are available, how we can tweak the indexing so that the data is indexed more efficiently and easy to track the indexed chunks based on the input query. So I spent so much time in learning about the indexing. And for WSP, we had a requirement that we need to integrate this chat module in a web page that is running in React.js. So I also don't know anything about the React.js at the time. So I was just going through the basics to creating a simple web page or how to integrate with the AI module. But I haven't completed. I haven't gone through anything detailed in the React.js. But I know some basics to deploy a web page and to attach the backend to the page. And next one is the Microsoft authentication. We already deployed one simple page to authenticate using the Microsoft credentials, Azure credentials. But still we need to work on this Microsoft authentication to deploy it in our module. And prompt engineering. Okay, prompt engineering is I don't know, for each and every use cases I'm learning new methods of giving the prompt engineering. For Amplitude was different case. For WSP, for LTEL or Mariora, I've been updating my knowledge on prompt engineering for each and every use cases. So still I have a lot of things that I have to study on this prompt engineering to get the right results. And the model training, this is the first time I do the model training for OpenAI models. Previously I did for a normal open source model, but this is the first time I'm using the OpenAI models. So the way forward, I think as suggested by Timo, I need to go through the A2A protocol for how the agents are communicating within the same module, within the same execution workflow. And also MCP. I already started learning that using the open source fast MCP. I was just interacting with the already deployed MCP servers, like free MCP servers, giving the free services, and interacting with the agent workflow that we created using the Llama Index and LangChain, which are LangGraph. But I have to go through it completely to understand in deep how the MCP is configured and how to create the manual MCP server. Suppose if we need to deploy our own knowledge base, then we need to set up a manual MCP servers. So in the future, in the way forward, I have to concentrate more on A2A and MCP. And The problem now is I have created a different models for different use cases for different clients. So it is being scattered all around. So what I have to do is I have to integrate all these things together from different modules and just give it as a single one module with having all these features, all these independent modules that we develop. So I need to do that also in the coming weeks. And the next one is a decoding complex blueprint diagram. From the last year itself, we're having this problem for understanding the blueprints, industry blueprints. So we haven't figured out how to solve this problem. So maybe this would be a nice nice thing to spend time on this one. And prompt engineering. So yeah, day by day the prompt engineering methods are changing, techniques are changing. So I have to be I have to go through all these latest developments in prompt engineering, so that I can able to utilize its advantages in our module. And lastly, the authentication module for authentication type, whether we're using the Microsoft authentication or simple Streamlit framework authentication, or any other professional React.js or this kind of framework, JavaScript framework based authentication or not. So you still have to think about, and I have to learn that based on our requirements. So yeah, I think this might be definitely it will be more than 5 to 10 minutes. So anyhow, I'll try to comprehensively give the idea about what I did in last 6 months, what I am going to do, or what I was thinking to do in the next 6 months. So yeah, thank you.